Humanity has always been fascinated by the sun. For millennia, we have worshipped it, defined our lives by its light, and slowly, we have begun to understand its immense power. Now, we are taking another giant leap in our quest to comprehend our nearest star. This is the story of Aditya L1, India's pioneering mission to gaze directly into the heart of the sun. Launched by the Indian Space Research Organization, Aditya L1 is not just another satellite. It is the country's first ever space-based solar observatory, an ambitious endeavor to study the sun in ways never before possible for the nation. Initially conceived as a smaller satellite to observe only the sun's corona from a low Earth orbit, the mission's scope was dramatically expanded. Scientists realized that to truly unlock the sun's secrets, they needed a continuous, uninterrupted view, free from the eclipses caused by the Earth itself. This led to a new, more challenging destination, a special point in space known as Lagrange Point 1. Imagine a point in space, about 1.5 million kilometers from Earth, where the gravitational pull of the sun and the Earth balance each other out. This is the L1 point. An object placed here can remain relatively stable, essentially parking in space, allowing it to orbit the sun in perfect sync with the Earth. Aditya L1 was sent on a 110-day journey to reach this location. Upon arrival, it maneuvered into what is called a halo orbit, a complex, three-dimensional path around the L1 point. This orbit ensures that the spacecraft can continuously view the sun without any obstruction, providing a constant stream of invaluable data. The scientific objectives of Aditya L1 are as ambitious as its journey. The mission aims to unravel some of the most profound mysteries of solar physics. The primary goal is to understand the dynamics of the sun's upper atmosphere, its chromosphere and corona. One of the most perplexing questions in solar science is the coronal heating problem. The sun's surface, the photosphere, is about 5,500 degrees Celsius, yet the corona, the outermost atmosphere, sizzles at over 1,000,000 degrees. How the corona gets so incredibly hot is a puzzle that has baffled scientists for decades, and Aditya L1 is equipped to find crucial clues. The mission will also study the very origins of violent solar events, like coronal mass ejections and solar flares. These are massive eruptions of plasma and energy from the sun that can travel across the solar system. When directed towards Earth, they can have significant consequences. With all the advanced instruments on this mission pointed at the sun, what specific solar mystery are you most hopeful that Aditya L1 will help us solve first? These solar eruptions drive what is known as space weather. While space may not have weather in the way we experience it on Earth, it is filled with a constant stream of charged particles from the sun called the solar wind. Disturbances in this wind and powerful events like CMEs can interact with Earth's magnetic field, causing geomagnetic storms. These storms can damage satellites, disrupt communication and GPS signals, pose a radiation threat to astronauts, and even cause massive power outages on the ground. By studying these events from its unique vantage point at L1, Aditya L1 acts as an early warning system, tracking Earthbound storms before they are influenced by our planet's magnetic field. To achieve these goals, Aditya L1 carries a sophisticated suite of 7 indigenously developed instruments. 4 of these payloads are for remote sensing, meaning they observe the sun from a distance, while the other 3 are in situ instruments, studying the local environment of particles and fields at the L1 point. The primary remote sensing instrument is the Visible Emission Line Coronagraph. This payload creates an artificial eclipse, blocking the bright light from the sun's surface to get a clear view of the much fainter corona. It studies the dynamics and origin of coronal mass ejections and measures the magnetic field of the corona. Then there is the Solar Ultraviolet Imaging Telescope, which captures images of the sun's photosphere and chromosphere in near ultraviolet light, providing crucial information about flare activity in the layers just below the corona. Two X-ray spectrometers are tasked with studying solar flares by observing the high-energy X-rays they produce. The in-situ instruments provide a different perspective. The Aditya Solar Wind Particle Experiment and the Plasma Analyzer Package for Aditya work together to study the solar wind. They analyze the direction, energy, and composition of the particles, like protons and alpha particles that flow constantly from the sun. Finally, a triaxial high-resolution digital magnetometer measures the strength and direction of the interplanetary magnetic field at the L1 point, providing context for the particle data collected by the other instruments. Together, this suite of instruments provides a comprehensive look at the sun and its activity. By combining data from the different payloads, scientists can trace the sequence of events from the sun's surface through its atmosphere and out into space. This integrated approach is key to understanding the complex chain of processes that lead to major solar events and drive space weather. The data from Aditya L1 isn't just for Indian scientists. It has been released to the global scientific community to maximize its use and foster collaboration. The mission represents India's significant contribution to our collective understanding of the star that makes life on Earth possible, securing its place among the major space agencies studying our sun.